have received a number of interesting questions. It's an interesting assignment. I hope you realize that by now. You learn a lot by doing that assignment. And I've received a number of questions. A lot of the questions are based on one fact that I already told you. The assignment, what I asked you to do is an impossible question. So it has no answers, but no answer is not an option when you're out there, right? When you're in the financial sector. So you have to come up with those yield curves one way or another. And depends on how you do, then everything in the assignment is going to be a function of that. So for example, some of you, I think most of you, have calculated the yield curve at the points where you had bond maturities. Perfectly good. You could have done something different, which you could have said, I'm going to calculate the yield curve at some made up dates, for example, 6 months, a year and a half, 2 years. And since you don't have maturities at those points, you interpolate and you say, well, if these are my unknowns, the maturities that I have will imply these rates at those times. And then you will have different curves. And those will be very different curves, because in one case, you're going to have a jagged curve that has kinks at every time you had a maturity date. And in the other one, you're going to have kinks every time you chose to say, I'm going to pick this or that rate. And both are wrong or right, or right? You understand that? I think you understand that by now. Good. Now, it's very important to realize that once you get to the yield rates, the yield curves are independent of the bonds. So when you go to the next part of the question, which is calculate the covariance matrices, whatever the bonds were, you don't care. How you got to the yield curve, you don't care. Now these are curves. And you're going to calculate the covariance matrix from the curves, with disregard of the original data that gave rise to the curves. That's very important. That's how you make a hard problem easier. Once you got the curves, these are your curves. And the bonds that gave rise to the curves don't matter anymore. Is that clear? That's how you think. In fact, in practice, those yield curves may be given to you by some quant people, some mathematicians in a different department, right? Maybe you're not doing all the work. Maybe you're the bond trader, in which case someone gives you the curves, and frankly, you don't have time to figure out how someone got those curves, right? That's how it works. Now, once you have the curves and you have to calculate the variance-covariance matrix, what you need to understand is the variance-covariance of what? It's very easy to make a mistake, because now you're dealing with a lot of numbers. I mean, not a lot of numbers. You're dealing with 5 times 10, 50 numbers. That's not a huge amount, but you have a 5-dimensional vector moving through time, a 5-dimensional random vector. So when you calculate the covariance matrix, it's going to be a 5 by 5 matrix, not a 10 by 10 matrix, right? You need to understand where the source of randomness is. That's what you're trying to capture. Don't make that mistake. Yeah? It's clear once you understand it, but if you're just trying to blindly apply formulas that you have that give you a covariance metric, you take a summation. Summation of what? You put the wrong index, you get something completely nonsensical. That is wrong, right? And something important, why did I ask you to do the covariance matrix of the returns of the yield rates? There's something very deep there. When you look at the returns, I'm talking about somehow the percentage change, not the actual rates. Some of you who are good in statistics will know the answer. The reason is that the rates, the sequence of rates is an autoregressive sequence. And you cannot calculate the covariance matrix of an autoregressive sequence. If you have an autoregressive sequence, you have to take what's called the derivative of the series. That series has a unit root. You may have heard this term in statistics. So you have to remove the unit root by taking what happens to be the return, what in finance we call return. But in statistics, it's called the derivative of the series. If there's a unit root, the covariance matrix has no meaning. You need to have a series which is identically distributed. And we're taking that difference divided by yesterday's return expression so that what results is identically distributed and independent. You understand? That's very important. For the assignment, you're just asking, you're just doing what I asked you to do. But I want you at this point to understand that the reason I asked you to do that is if you do what many people do, take the covariance of the actual rates, what you get has no meaning. You're breaking the laws of statistics. Not a good idea. I don't know if you understand that. You don't have to understand this. I explicitly told you in the assignment what you have to do, but it's good at this point today when you've been working on that to understand that there's a deep reason why you have to do it like that. Yes? Good. Another thing is when you're doing the variance covariance matrix, again, you do it on the curves. You already have the curves, and whether the curves have your kinks here, your kinks there or something, these are curves. You just evaluate the 1-year rate, the 2-year rate, wherever the curve gives you those values. That's what you do. You're dealing with curves. You're not dealing with bonds anymore. Yes? Okay, very important. And by now, some of you would have calculated the first eigenvector, which is the most interesting one. Anybody has calculated the first eigenvector? What do you get? 1, 1, 1, 1, 1?
Yeah.
Yeah, exactly. You're supposed to get that, right? If you don't, you call it. And then you get the second eigenvector, which is probably going to be not exactly minus 1, but something like that, right? The analogy with a sine function should be clear when you do that, okay? Except in the same function, when we looked at music, your string is tied to the ends. In this case, they are not tied to the ends. So that's why they can be all ones. They don't have to be 0 at the ends. Yes?
Is that we should get also normal basis?
Say that again?
Is that we should get a normal?
Oh, you have to get an orthonormal basis. Then you're breaking the laws of math, and that is highly illegal. You can't do that. Yeah, you know that the eigenvectors that arise from your covariance matrix have to be orthogonal to each other. Yes. The eigenvalues are all different. Yeah, incredible numerical coincidence that two of them are the same. So they will have to be different. You saw that in linear algebra. Yeah. And in doing that, you've done the spectral decomposition of the fixed income market. That's a very big deal. And that's knowledge that very few people have in the whole world. You're one of the few. Okay? That's assignment number 1. Now, I think I've answered all the questions that I got in all of the media and here and this. Are there any more questions on that? Assignment number 1. All good? Yes?
I noticed in your solved examples when you did months for the making the price dirty, you did it in multiples of 30. For our project, are we expected to also do each month as 30 or the exact number of days?
Okay, so I forgot exactly how it was written on that. That's another good question. So let me tell you, the tricky part there is when we say number of days since the last coupon payment. Number of days, what days? Work days, weekdays, holidays, weekends. These things matter a lot in real life, a lot. You cannot, if there's a holiday somewhere, you have to take it into account. Here, I don't care. So you have that leeway. You can, and normally what I would like to do is I would have to say, you can round everything to the nearest month even. Like it's a gross exaggeration. People will kill me if in the banks they hear I'm telling you to do that. The reason is that I don't care about day counts, right? I don't care. That's not why you're doing this. There is a taken function that you can invoke in Excel, in Python, this and that, and if it gives you the right number, fine. If it doesn't, I don't care. Ask the TA, she may care, okay, but I don't. It's not an interesting point to belabor when it comes to doing the assignment. Okay, I on purpose, I've removed all the noise I could from the assignment so you can narrow in on what really matters in that assignment, which is to understand how fixed income markets work. Everything else, yeah, you have to do that. You have to have some sort of a day count. And sometimes I myself, when I do this for examples like that, I don't know what I do. Okay, because I'm trying to narrow in on what matters, which is the value of time. And whether you take holidays or weekends into account, not a big deal. Is that what you're asking? Again, this is a course which is very generic. You see, every day we do something different. So when it comes to details like that, this is a bond that's issued in Canada. Shall I take into account Thanksgiving weekend in the US? Probably not. Check the bond, okay? Who issues the bond and these things like that. So when you're out there, these things matter, but here in this classroom, that doesn't matter. All good? Are you in good shape to do something wonderful with that assignment? The assignment, not only you'll submit it and this and that, I would, to some job interviews, I will carry it with you, to show people that you can actually know this stuff. You've done that. Good.